Alexa, turn on office lights.
Okay.
Alexa, turn off office lights.
Okay.
Alexa, turn on kitchen lights.
Okay.
Hey, what's up? Nasser Malik here. Welcome to another home automation IoT tutorial. In this tutorial, we will be programming an ESP8266 ESP-12E chip. I will add all the links and a GitHub project link in the video details below. So I want to recognize this guy. I hope I'm pronouncing the name right, Kakupapa. All the code that I'm using for this project is based on this project with a little bit modifications. So thanks to him creating this emulator for remote switch. So let's look at the components that are required for this project. We need Amazon dot or Echo. We need FTDI USB to TTL converter, mini USB cable, a breadboard, assorted breadboard wires, ESP8266 ESP-12E board, soldering iron and resin core, a mechanical relay, a solid state relay, and a prototype PCB board. So this project requires a little bit of soldering if you're using this chip, but if you have a version with the programmer, then you don't need to do soldering. So if you have one of these boards or similar board, then you don't need to do soldering. So let's look at the cost of the total project. So serial converter is about $2. The ESP8266 version 12 is $3. Solid state relay about $4.50. $1.50 for mechanical relay, $1.50 for breadboard wires, and $1.50 for PCB board. Total cost is $14 for this project. So let's look at the steps. Install and set up Arduino IDE. I'm not going to do this in this tutorial. You can watch my tutorial 1 for this series. That shows you a detailed step-by-step how to install and set up Arduino IDE for ESP8266. Solder ESP8266 version 12 board to a PCB board. If you're using a development board, then you can skip this step. Connect the FTDI converter board to ESP8266. Flash ESP board using Arduino IDE. Connect mechanical and solid state relays to ESP board. Power up the ESP and relay boards. Control both relays with your voice command using Alexa. So let's look at how to connect your FTDI board to ESP8266 board. So you can see on the layout on both boards, they're labeled. So if you look at the FTDI board, we have the very bottom pin is ground. You skip one pin, and then the second pin from the bottom is 3.3 volts. And then the fourth pin is TX, and fifth is RX. So we're going to be using these 4 pins to connect our ESP board. So basically, your RX connects to your TX pin on the ESP board, and your TX connects to RX. 3.3 volts will be connected to VCC and EN pin on the ESP board. And the ground will be connected to ground of the ESP and GPIO 15. To put the ESP board into the flash mode, we'll need to connect GPIO 0 to ground before we boot the board. Let's take a look at the wiring diagram. First, we need to connect TX to RX from ESP to FTDI board. Then we need to connect RX to TX. We only need these two connections when we need to flash the chip. Next, we need to connect EN in VCC, which is pin 3 and pin 8 to 3.3 volts. Then we need to connect to GPIO 15 and ground to the ground or negative. So before we boot the board, we need to make sure we connect GPIO 0 to the ground. This is to put the chip in a flash mode. If you don't do that, you won't be able to flash your program into the chip. So next, let's look at the wiring both relays to the ESP board. So the way the both relays are connected is a little bit different. If you can see on the solid state relays, there's only two connections, positive and negative. Mechanical relay has three connections there, negative, positive, and a signal pin. So to connect the mechanical relay, we need to connect the S pin or the signal pin to GPIO 16. I'm using GPIO 16 and 14 for this project. And for solid state relay, you'll connect the positive terminal to the GPIO 14. Very simple. And the negative will go into the ground, and this negative and positive will go into the ground and 3.3 volt. So the difference in the both relays is the mechanical relay, you'll hear a sound in there, and it's rated for 10 amp up to 250 volts. On the other hand, this relay, solid state relay, can be operated from 3 to 32 volts DC, and it's rated up to 380 volts, 40 amps. So this can drive a lot bigger load than this relay. So everything put together, this is how it looks. So this is my setup, and we'll walk through this step by step, connect everything. So I want to explain a few things here. So if you take a look at it, I will supply the 3.3 volts here, positive, negative, and I'll use this to power up everything. So if you look at the relay, negative goes into the negative, positive goes to the positive, doesn't matter where you connect it. And the signal one goes to the GPIO 16. So if you count 1, 2, 3, the fourth one is from the top, it's GPIO 16. So this is a pin 1. This is pin 2, 3, 4. The fourth one is GPIO 16. On the solid state relay, I connect the positive terminal to the GPIO 14, which is the fifth from the top. 1, 2, 3, 4, 5. And then the ground goes into the ground. To power up the ESP board, I'm connecting the last pin on the bottom to the positive. So this pin right there goes to the positive. And this pin, last one, is a ground, and that gets connected to the negative. These two connectors are only connected when we want to flash the board. So the TX goes to RX to your FTDI board, and then RX goes to your TX FTDI board. So one more thing I would like to mention, I connected the EN pin right here, pin 3, and the 3.3 volt VCC. They're connected through a wire underneath it, and makes it simple to power up the board, and less wiring needed on a breadboard. And also the ground pin on the board is connected underneath the board with the GPIO 15 pin, which is 16 and 15, both are connected. And when I want to flash it, what I do is unplug the power, and then with tweezers I'll connect the ground pin 15 to the fourth pin right here from the bottom, which is GPIO 0 or pin 18. I just short them and then power up and then let it go, and the chip is in the flash mode, and I can flash it. So I will talk about the board. Since the board size and the pin size is not meant for the breadboard, so it's really difficult. I tried to solder the board directly using the breadboard wires, but it's very messy. So I created this a little jig. It didn't take me much time, like 20 minutes to solder up the whole thing. You need 2 centimeter pins connected here, and then the breadboard soldered to the breadboard. This is not solder because I have multiple boards that I need to program, so I needed something quick, so I can pop this out, pop one back in there, and program it and play around with it. The rest, I use the 2.5 centimeter pins underneath this PCB board, which, you know, it's pretty nice. So here are the things we're going to need for this project. So let's look at this jig that I just created. It's pretty simple and easy. It actually, if you look at it, it just pops out easily. Just have to be careful not to mess up these pins. So if you can look at these pins, they're a little bit on the angle, so it makes a good connect with this board. This board is pretty small. So these pins right here, they don't take the standard big pins, the 2.5 millimeter, and it's not breadboard friendly. Let me just put this in. So this is how it gets put in. So you basically, it's pretty easy to. So line up one side like this. So once it's lined up, on the other side, if you look at it, it's a little bit of off. So you just kind of like press the board on the sideways, like push it on this side, push it on this side, and it will just pop in like that. So now it makes a very good connect. You don't need to wiggle it to get a good connection, and it's pretty nice. So the one thing that I want to mention is to minimize the wiring on this, because this is pin 1 from this, and then count down. So the third pin from this is the EN pin that requires positive voltage, and also the pin 8 needs 3.3 volts. So what I did is I connected. So instead of wiring it every time, I just connected to a small wire underneath the board, so you can see it. So if you take a look at it, just took a tiny wire and connected it to this one, so it doesn't matter which one gets powered up, they both get 3.3 volts. So on the other hand, to power up this board, you need the ground connected onto the pin 15, and also the the ground connected to pin 15, and also the GPIO 15, which is pin 16, it needs the ground. So they're connected from underneath the board. If you look at it, they're kind of like, I put a small wire in and soldered them together right there. I don't know if you can see it clearly or not. Let me see. Yeah. So right there, these are together. So that's it. So underneath it, this EN to 3 volt VCC, and these two, you just hardwire them, and you're done. So this way, when you just give it a voltage 3.3 on this pin or this pin, they both get powered up, and then ground. These both are ground. And to put it in a flash mode before you power up, you need to make sure that you connect GPIO 0, which is pin 18, on the this right here. This pin needs to be connected to ground to flash it. So what I usually do is I just kind of like grab these two pins like this with my tweezers and power it up, and then let it go, and I'm good. I'm in a flash mode, and you just flash it. So that's pretty easy. Okay, so we're gonna wire this thing up now. So I'm gonna just connect this to the breadboard. It goes in like this easily. And next I'm going to do is take the FTDI board, and so basically the pins are, the first one is ground, the third pin is 3.3 volt VCC. Make sure this is jumper wire is set to 3.3 volt, not 5, because you can switch this over here. If you connect it to the first one and the second one, it'll be 5 volts. So and then this one is a TX, and then second last pin from the left is the RX pin. So if you look at the wires, so the black one is gonna go to negative, red is positive, the brown or whatever the color is, it's TX, and that needs to go into RX on the ESP, and this is RX that goes through the TX on the ESP board. So let's connect this. So if you take a look at it, so I'm going to see if I can put it on the angle and connect these wires. So the black one goes to the ground, so I'm going to put that there. So provide the ground, and this is for the positive volts. So this is this step is to flash it. So I'm providing the negative and positive to the whole rows here, so I can hook them up and connect them. So now we know the first wire on this is RX, the white one, and the second one, the brown one, is TX. So the white one goes into, the white one is gonna go into this connector right here next to this one, because this is TX and this is RX. So then we put the white wire here and the brown here. So I'm going to connect that. Okay, so we're good with this. This is gonna hook up to your PC to flash it. So for this wiring to hook this board to the breadboard, we're good here. So once we're done programming it, we can unplug these two, and then we're good. So next, what I did is to provide 3.3 volts to the ESP board. I cut this little wire. It's easier because if I use the regular wires, it kind of makes it messy and cluttered, so it's harder to understand which wire goes where. So I'm going to connect this to the 3.3 volt pin on the ESP board. So basically, if I can see it through the camera, it's a little hard sometimes. Yep, like that. You just press it in, and you can see this is connected. So you can see this 3.3 volt is connected to the positive, which is this positive in this row. And then it's also, because underneath it I connected it to a wire to the EN pin, so they're both are gonna get 3.3 volts. So next, for the negative, I cut up this short little wire, so it's easy to see where we're connecting the wires. So I'm gonna connect this to here, the ground pin for the ESP board, and then I'm going to connect this to the negative row right there. So from the FTDI there is a negative coming, so on this row, so that gets connected to the negative. So that's powering up the ESP board, and let's hook it up and flash it. So I'm going to connect this. It's not connected to the computer yet. So as I told you, when I'm going to power up, I'm just going to grab these two wires and short them right there. I mean, you can put a switch here. I didn't do it because then more wires, and it makes it more complicated. So I want people to follow through the tutorial, and visually it's easy to follow. So before I connect it to the computer, I'm gonna with tweezers, I'm gonna short these and then let them go once it's powered up. So let's take a look at it. Let's do that. So to upload the program, we open up the Arduino IDE. Open up the project that you downloaded from GitHub. A few things you need to change here. The very first thing is this SSID. You need to make sure you put in your access point or Wi-Fi router name here. Make sure you connect it to 2.4 gigahertz router. It doesn't work with 5 gigahertz. In here you put in a password for your router, and you need to make sure that you connect to the same network Amazon Echo or Dot is connected to. Also, I'm using GPIO 16 and GPIO 14 on ESP version 12E board, so you can change it if you need to use different pins. To flash the board, you need to go first and make sure you select the Node MCU version 1.0 ESP-12E module. You select that, and then whatever port you have, you select the port, and basically from there on, once you put your board in the flash mode, you can upload, flash it, and then it's going to compile. We can wait, and so I'm gonna show you guys something. I actually didn't connect the positive wire correctly. So the positive wire was connected on a wrong slot in here, on a wrong pin. So I fixed it, moved it here. So I'm going to put the chip in a flash mode again and try to upload the firmware again. Let's click and upload. It's compiling and it should upload shortly. And you should see the LED blinking on the board. So as you can see, the LED is blinking on ESP board. So it is flashing. So once it's completed 100%, I will remove the RxTX pins. I'm going to also open up this the serial console, and once it's flashed, it's gonna show you the IP address of your the ESP board. At this point, it is connected to your network. So while you're flashing the ESP board, open up this serial monitor, and you should see a similar output from your board. This tells you, you know, that it is connecting to this your network. It's connecting to your router, and it obtains the IP address. That means it's on the network, and the rest of the information for the board. So once this is connected, so basically now what we're gonna do is we're gonna unplug the RX and TX, the communication wires, and then hook up the relays and ask Alexa to discover the device. Even before you actually do that, let's hook up Alexa and then ask it. So while you're flashing your board, ESP board, you could click on this icon right here, serial monitor. It'll open up this window. Once it completes flashing, it's gonna restart, and it's gonna give you a similar output. If you look at connected to, and this is going to be your Wi-Fi router name that you put it in, and once it obtains the IP address, it will show you the IP address here, and this means your ESP board is connected to your network at this point. So what we're going to do next is we're gonna have, before we unplug anything, we're gonna go ahead and ask Alexa to discover devices and to make sure that everything is connected, and you can see the output, and that should match similar to my output, unless you're gonna have a problem if it's not connected correctly. So let's do that first. So I have the Alexa dot here, so I'm going to give a command. So let's see what happens on the serial output. Alexa, discover devices.
Starting discovery. This can take up to 20 seconds. If you have Philips Hue, press the button on your bridge.
So as you can see, it actually send commands, and
discovery is complete. I found 2 smart home devices. If your Philips bulbs were not discovered, please press the button on the bridge and rerun discovery.
So as you can see, it discovered 2 devices, even though we only have just one board hooked up. So you can use more GPIOs on it and set it up in a program, and you'll be able to control multiple devices with single board. So we're gonna go ahead and give just commands to turn on and off thing, and we see serial output if we see anything happening, and then we'll just go ahead and plug in our relays with it to make sure that it can control the relays. Alexa, turn on office lights.
Okay.
As you can see, it just sent the command to turn on one of the devices. So the output is going to be similar. So as you can see, we haven't hooked up anything yet, but we're gonna go ahead and hook it up in a minute. But I want to make sure that it's able to discover 2 devices and able to send commands. You want to test it before you hook up anything else. Alexa, turn on kitchen lights.
Okay.
So this looks good. It's working. So what we're gonna do is we're going to go ahead and plug in both relays. So the plugging in relays, it's very easy. So very first thing we're going to do is plug in this solid state relay. So I got these 2 wires hooked up to the solid state relay here, one to the negative and one to the positive. The positive one goes to the GPIO 14, and this one goes to the ground. So as you can see, As you can see here, this is ground, so I'm going to plug this in here, and this is done. And also this goes to the GPIO 14. Before I do that, I'm going to actually unplug the FTDI board, so I want to power it down. I don't want to short anything. Power it down. So I'm going to do is connect this to the GPIO. So if you count from the top, it's 1, 2, 3, 4, and the fifth. So this one is GPIO. Fifth one is 14. So I'm going to put this there. So 1, 2, 3, 4, 5. So there we go. So now we're going to take the solid state, the mechanical relay. So we have the negative. So we have the negative goes into the ground, positive go to the 3.3 volts, and the signal goes to the GPIO 16. Even though this is a 5-volt relay, it still I'm able to operate it if we have enough juice. So let me connect this. So the ground goes to the ground. The red one goes to the positive, and the signal goes to the GPIO 16. There we go. That's it. We're connected, and we don't need these two wires to flash it. This is only needed to flashing it. So I'm only powering up the board actually with these two wires, using the power from it, and that's it. So on this relay, when I give commands, you're gonna see this light coming on and off. I don't have any hooked up here, anything, but I just want to make sure you guys can see the light coming on and off. Turn on office lights.
Okay.
Alexa, turn on kitchen lights. So something is connecting. So something is connected wrong. The solid state relay is connected wrong because it didn't turn on. Let me check what's going on here. So guys, looking through the camera, it's really hard to figure out the port. I can't see it very well. So I had it hooked up on the wrong pin here on the breadboard. So I had to move one up. So it's the first, second, third. The fourth one is the GPIO 16, and then the fifth one is GPIO 14. So let me try it again. Alexa, turn on office lights.
Okay.
Alexa, turn off office lights.
Okay.
Alexa, turn on kitchen lights.
Okay.
Alexa, turn off kitchen lights.
Okay.
So guys, please give me a feedback and tell me what you like about this tutorial, what you don't like. And also, if you guys can let me know what you like me to cover in next few tutorials. These are the basic building blocks. Eventually, we're going to be creating the whole automation system for the house, where we're going to be connecting different things to a single console and control it that way. These are building blocks. I have not showed you a project where you actually put everything together. So I think next few tutorials we're gonna get the basics done, and then we're gonna build these small devices, and I'm gonna show you how to connect them to your lights or your fan or different devices that you like to connect to. So folks, this is it for this tutorial. Until next time,